In simple linear regression, we have a hypothesis, but we have a hypothesis that the TV ads, for example, and cars sold are positively related. The higher the amount of TV ads, the higher sales are expected, and vice versa. So there is a proposed linear model, or we suspect at least, that they are positively related and that they might be linearly related, so that the proposed relationship is that y, that is sales, is equal to a vertical intercept plus a slope times x plus u. And let me explain what each one is here, where y is the dependent variable of sales, x is the independent variable of TV ads. This is the variable that explains the dependent variable. For example, if an instructor is investigating how absences influence grade, well, number of absences will be the independent variable and grades will be the dependent variable. You have to decide that when you are analyzing two variables, which one you think is independent, which one you think is the dependent. B0 is a beta 0 is the vertical intercept of the line, and beta 1 is the slope of the line. And u here is all other things that may influence y, other than the independent variable TV ads. The simple linear regression technique consists of the following. You use it typically in softwares like Excel, which is going to be shown in a moment, to estimate the linear relationship between x and y. You have to use a sample, of course, to see or to verify or to check the extent to which the two variables are linearly related. You are going to obtain a line, and the equation of the line will be y equals vertical intercept plus the slope times x. But the sign plus could be minus. It all depends on the kind of relationship between the two variables. In our case, it is a plus because we think the higher the TV ads, the higher the sales. Y is often referred to or is shown in the textbooks as y hat, or y with a little hat on top. The most important interest in simple linear regression is the relationship between x and y, and by analyzing the statistical relevance of the model, and specifically the statistical reference of B1, whether B1, the direct relationship between x and y is relevant. And remember, B1 is the slope of the variable of the line is the vertical change divided by the horizontal change. So it is how much y changes when x changes. So an example will follow. The example is this one. We observe in 5 weeks TV ads of 1, 3, 2, 1, and 3 for each week, and the amount of cars sold 14, 24, 18, 17, and 27. We're just using 5 observations. And I have the same numbers here in Excel. TV ads 1, 3, 2, 1, and 3. Number of cars sold 14, 24, 18, 17, and 27. The very first thing we should do is to try to verify what kind of relationship, or to check what kind of relationship we have between the two variables. So for that, we just go to Insert and then Scatter Plot, and let me select the data first. And if you notice, I have positioned the TV ads first and then cars sold. In Excel, automatically you'll have that as interpreted as TV ads being the independent variable and then cars sold as the dependent variable. So we don't need to make any arrangement. because it's already arranged for X and Y. Notice how X will be on the horizontal. The TV ads vary between 0 and 3, and the cars sold are on the vertical, which changes between 14 and 27. It's a very simple exercise. Very few observations, but you can extend this analysis to more data. If you right click on any of these dots, you can actually add a trend line. If you notice, you're going to see it automatically, and that Excel shows you a possible linear relationship between these two variables. And you can actually click on a box here, display the equation on the chart, and you'll have the equation as y is equal to 10, the vertical intercept, plus 5x, or you can write it as 5x plus 10. Now, using regression analysis, you can go to data, and then data analysis. Then here you select regression, click OK. Then you have to specify the wide range, which is cars sold. Notice that I'm selecting I'm including in my range the labels. So I'm going to check this box here. And the X range, you can actually click on the red arrow here and then select the range. But sometimes I just click inside the box here and I select the X, which is the TV ads. And make sure that you have both ranges the same amount of observations. Notice that Excel by default has a confidence level of 95%. So we're just going to leave it like that. And we're going to obtain the results in either a new worksheet or an output range. Let me just select an output range, and I'm going to select this range, this cell here. Click OK, and these are my results. The very first thing you should notice is that the equation that we're looking for is right under the coefficients results here at the bottom left. Notice the equation is y equals 10 plus 5x. Here that's what you have. 10 is the vertical intercept, notice. And then we have a positive 5 for TV ads, so that it means plus 5x. So this is our equation. Second, from all these results on top, you just look at R squared. R squared indicates the percentage of the variation in y explained by the variation in x. In other words, how much of the variation in TV ads information or numbers explain the variation in cars sold. And this is a relatively high percent. That's 87.7% of the variation in cars sold is explained by TV ads. So that's a good result. And that is the interpretation of R squared, which is an important information for our model. There are other information here that we are not going to use because this is more the subject of the second statistics course. But in class we learned that to obtain test statistics, and we usually test or contrast or compare the test statistics with a critical value. And that critical value at 95% is usually 2. And we learned that if our number is greater than 2, then our number is statistically, we have to reject the null hypothesis, if you recall. And that's what we obtained here, 4.6291. Well, Excel by default, if I'm here, beta 1, or the slope that we hypothesized in our first slide. This is the population slope coefficient. And Excel, as you may remember in class, the alternative hypothesis is that beta 1 is different than 0. So that's what Excel does automatically by default. So in other words, we're testing whether beta 1 is equal to 0 or is irrelevant. And by finding 4.629, we find that we have to reject the null hypothesis. And if we reject that beta 1 is 0, that means that beta 1 is significantly different than 0. And this indicates that beta 1, or B1 that we obtain from our sample, and finds enough evidence to reject the null hypothesis that beta 1 is equal to 0. Right? Now, one easier way to find the relevance of beta or B1 is that we compare the p-value to alpha. Since alpha is 0.05, remember that from class, then if the p-value is less than alpha, then reject the null hypothesis. That's what we learned in class. Well, the p-value is 0.018, which is less than alpha, or 0.05. So we can automatically reject the null hypothesis. And here, this is lower 95, upper 95. If you notice, there is a 1.56 and an 8.43. These are the range of values, if you remember the confidence interval. According to Excel results, the value of B1 will be found between 156 and 843 from the sample. And this is like a range of values. And if you notice, between these two values, you don't find 0, which is the null hypothesis. So that also verifies the result.